Unit 12, Day 4. This is Ms. Maria with our Day 4 of Trigonometry Notes. So the first question, a little bit of review. Which of the following angles have a reference angle with a measure of 30 degrees? Well, first we must take a look at what a reference angle really means. It is the angle formed with the x-axis. When we take a look at our unit circle, we're going to go around these angles and see which ones have a reference angle of 30 degrees. So first, we're going to go around 120. So we're going to start over here in quadrant 1. We're going to go counterclockwise. So we're going to go 90 degrees and then 30 more. So we're in quadrant 2. Now, if we've gone 30 degrees into quadrant 2, that means there is 60 degrees left. So, number 1 is no good. 150 degrees, negative. So we're going to go clockwise this time, 150 degrees. So we go 90 degrees across quadrant 4, 60 degrees into quadrant 3. And that leaves us with 30 degrees remaining. So that 30 degrees is our reference angle, so that one's good. And now 330 degrees. We're going to go around counterclockwise again. So we go 90, 180, 270, and then 60 more. When we do that, we're left with 30 degrees remaining before we reach a full circle. So our reference angle is 30 degrees, so number 3 is also okay. So 2 and 3, but not 1. Before we start converting between degrees and radians, we have to discuss a little bit about what we're really finding here. So first, a unit circle has a radius of 1 unit. Hence the term unit circle. Find the circumference. Circumference of a circle is 2 pi r, where r is our radius. Since our radius is 1 unit, our circumference of our circle is 2 pi. That means that our radius would lay along our circle 1, 2, 3, 4, 5, 6, and a bit. 6.28-ish. We could go around. The length of a semicircle of radius 1. Well, a semicircle is half of a circle. So if our entire circle's circumference is 2 pi r, then we would have 2 pi r divided by 2 to get us half of that. Our radius is just 1, so that gets removed, and we just have pi. What is the length of an arc formed by a central angle of 90 degrees? Our definition of a central angle goes out from the center of the circle. So 90 degrees, well, let's see, that's half of a semicircle. So that would be pi over 2. So we normally talk about, in prior units, talk about degrees of a circle, 360 degrees. We can also divide it up into things that are called radians. A radian is an angle of an arc that's measured by wrapping the radius of a circle around its circumference. So we take our radius, we lay the edge of it there, and then we slowly wrap our radius around our circle. So, because this is r equals 1, and our total circumference is 2 pi r, that means there are 2 pi radians in our circle. So, how about degrees? Let's see, we would have to take a 360 degree circle, and we would divide that by 2 pi, and that will give us our number of degrees per radian. So in our calculator, we will do 360 degrees divided by 2 times pi. Let's see, where is my pi button? Here it is, right here above the up arrow for a power. So we'll use our second key because it's in blue. We'll select that, close our parentheses, 57.295, yada yada. Or about 57.3 degrees. So Radian cuts the entire circumference and gives us 2 pi total radians in the circumference of our circle. So this actually tells us how we find pi. Because a radian is based on the pure idea of the radius being laid along the circumference, it gives simple and natural results to many angle-related mathematics. So we do not actually state radians when we do this. So if you think about it, we always write 360 degrees. We'll put the degree symbol there. But for radians, we just write the angle measurement. So pi over 4, let's think about this. If we started out on our unit circle, and we were going to go pi over 4 degrees, well, we now know that halfway around our circle is pi degrees. A quarter way around our circle is pi over 2. So 1/8 of the way is pi over 4, which is 45 degrees. Next, pi over 6. Well, okay, so the whole thing is pi. So for pi over 6 degrees, we're going to go 1/6 of the way around our first semicircle, or 180 degrees divided by 6, 30 degrees. Our next angle, 3 pi over 4. Well, if 1 pi over 4 is 45 degrees, then 3 pi over 4, we're going to go 1/4 of the way, 2/4 of the way, 3/4 of the way around. A total of 225 degrees. 4 pi over 3. Let's see. So pi over 3 would be 1/3 of the way across our semicircle. So 3 pi over 3 would be 180 degrees, or all the way across our semicircle. And then we would go another 1/3 of the way. 60 more degrees, or a total of 240 degrees. (11 pi over 6). Well, pi over 6 was 30 degrees back on question number 2. So we're going to go 11 times that, or 330 degrees. So starting in the first quadrant, 90, 180, 270, 360, 330. So Pac-Man. 3.0 radians. Units aren't listed, so we know we're working in radians. So what we're going to do is we're going to take our conversion of 360 degrees being 2 pi radians, and we're going to do 3 divided by 2 pi times 360. So grab our calculator. 3 times 360 divided by 2 and divided by pi. Oop, that's E. About divided by pi. 171.9 degrees. Or we could have taken 3.0 and multiplied it by our estimate of 57.3 degrees. Converting radians to degrees. 5 pi over 3. Again, for each of these, we have a choice. We can either do times 180 divided by pi, or 360 divided by 2 pi. This is usually the easiest. So we're going to cross out our pi's here. We'll have 5 times 180. 180 divided by 3 is 60. So 5 times 60, 300 degrees. 7 pi over 6. So we'll multiply this times 180 over pi. The pi's cancel out. 6 goes into 180 30 times, so 210 degrees. Negative pi over 3 times 180 over pi gives us negative 60 degrees. 4.1, that is in radians. So we're going to take 4.1. We're going to multiply it by 360 divided by 2 pi, or 180 divided by pi, which will give us 4.1 times 360 divided by 2 times pi. 234.9 degrees. 90 degrees, converting to radians. So 90 degrees is 1/4 of our circle. So we'll multiply that by 2 pi over 360. 2 pi over 4, or pi over 2. 225 degrees. And I may interchangeably use pi over 180 or 2 pi over 360. They are the same. So we're going to simplify our fraction. So 5/4 or 5 pi over 4. 120 degrees. Well, we know it's pi over 2 plus another 30 degrees, which is pi over 6. So 120 times pi over 180. We'll simplify our fraction here. 60 goes into 120 twice, and 180 3 times, so 2 pi over 3. And lastly, 315 degrees. 315 times 2 pi over 360. We'll simplify our fraction. This is 630 over 360 times pi. .75. So 7 pi over 4. Now, this is also the same as negative pi over 4. Either way is fine. And that is the end of day 4.